Yeah, hi everyone. Good evening. Let's wait 2 more minutes. We'll start at 7:05. Yeah, hello. So let's start off today's session. So if you remember yesterday, we were talking about different types of joins, right? So we saw inner join. We have seen inner join. We saw left join. Then we saw right join. Then cross join, right? So what is left out is self join. So yesterday when we talked about cross join, we talked about creating table aliases, right? So alias names for tables, and how to prefix table aliases with column names, right? So today we will use this idea of table aliases in order to see how self join works, right? Yeah, good evening, everyone. So self join, as the name suggests, you join a table to itself, right? So in all other cases, we had two tables. We were joining two tables, right? And in the case of self join, we are joining a table to the same table. So when you're joining two separate tables, we said there needs to be something called a common column. Right? Only if there is a column which is common to both tables, you will be able to join the two tables, right? Otherwise, it will not make sense. Unless, of course, you're creating a cross join, which does not need any common columns to be available, right? So just to remind you, yesterday we had a table called members, right? And we looked at a table called movies. And in the members table, we had four columns. We had something called the member ID, the first name and last name, right? I'll just write it as first name, right? And then there was something called the movie ID. And in the movies table, we had something called the ID column. Then we had the title of the movie, and then we had the category of the movie, right? So these were the two tables that we joined. So now, in order to join these two tables, the first thing that we did was we had to identify which columns are the common columns, right? Which is the column based on which we can join the two tables. And we found that the movie ID column in the members table corresponds to the ID column in the movies table, right? So this is the criteria based on which we did the join, right? So we joined based on the movie ID from the members table and the ID column from the movies table. And how did we identify that these are the common columns? We identified it because the values inside this, right? So the values inside the movie ID column actually comes from the ID column in the movies table, right? So this is why we say that these two are the common columns, right? So now coming to our self-join. The idea of self-join is these columns, right? So that we call our common columns should be present in the same table, right? Only then you will be able to join a table to itself. So let's go back to our myEMP table, right? So I will select only a few columns from myEMP. I will select the employee ID. Then I'll select the first name, the last name, and the manager ID, right? It's only these columns I'm interested in. So let's select only these, right? So from myEMP, right? I should have limited it to some 10 records or so. Let me limit it to some 15 records, for example, right? So that we can just look at those columns. Now here, if you look at these columns, right? So this is the employee ID of this person called Nina Kochar. 102 is the employee ID of the person called Lex, right? But what is this manager ID? What does this manager ID actually represent? The manager ID is actually the employee ID of the person who is Nina's manager, right? So who is that person? In order to find that, we go back to the same table and see that this number, right? So this manager ID happens to be the employee ID of the person called Stephen King. So that means Stephen King is Nina's manager. Right? Similarly, when you look at Lex, right? Who is Lex's manager? Lex's manager also has the employee ID 100. So the person whose employee ID is 100 is Lex's manager, right? So to find that, you loop back to the same table and you find that Stephen King is Lex's manager also. How about Alexander? Alexander's employee ID is 103, but Alexander is reporting to the person whose manager ID is 102. And who's that person? You have to go back and you have to find, okay, Lex is the person who is Alexander's manager. So you can see we are looping back to the same table and fetching data from the same table, right? So, so now which are the common columns here? Do you see any common columns in this table? Can I say that the manager ID and employee ID are the common columns? Right? Because the values in manager ID is actually coming from the employee ID column. Right? So these are the values that are coming into this. Right? So the employee ID of somebody happens to be the manager ID of somebody else. Right? So the common column here is employee ID and manager ID. Yeah, Rahul, that is correct. Right? So because the common column happens to be in the same table, I can connect this table to itself, right? So let's say, let me select once again. Let's select, let me clean this up. Let me clean this up and let me select it once again so that I can write it below this. So I will select these columns from manager, from myEMP, right? So let us say my myEMP table contains only 4 columns. For simplicity, let's just look at 4 columns. So now what I want to do is I want to join myEMP table to itself, right? So how will the connection look like? So this is my myEMP table. One more copy of myEMP table I will consider here. And I will say that this myEMP is being connected to this myEMP table, right? So what all columns do we have in myEMP? You again have the same employee ID column. You have the first name column, right? And then you have the last name column and the manager ID column, right? So these two tables are what we are connecting, right? So this is myEMP getting connected to myEMP itself. Now, what is the common thing that is connecting these two tables? You can see what is the common record here? Manager ID 100, right? So what is manager ID 100? 100 corresponds to employee ID 100 and Stephen K, right? So this matches with the employee ID of Stephen K, right? So let's ignore this. We are not interested in this manager ID. Similarly, if you look at this employee, right? His manager ID corresponds to this employee ID, right? So that is 100, which is corresponding to Stephen K. How about the third record? The third record corresponds to Alexander, right? And his manager ID corresponds to employee ID 102. And what is 102? 102 is Lex's employee ID. Similarly, what is 103? 103 corresponds to Alexander's employee ID, right? And so on, right? Alexander, Hunald, or somebody, and so on, right? So you can write the matching records here. So you can see this is as if I have written an inner join connecting these two tables. I have myEMP and I've connected it to myEMP, right? And I'm doing an inner join based on these two columns. What is the connecting column for me now? Manager ID in the first myEMP table and the employee ID from the second myEMP table. So this is the column that is connecting. So this is the one that I can use to join myEMP to myEMP, right? So this is the, this is the connection column here, right? So this is how I am joining. So manager ID from the first myEMP table to the employee ID of the second myEMP table. So in order to differentiate between the first and second myEMP tables, what we will do is, if we go on self-join, then what is the purpose of self-join? Purpose of self-join is to see if I want to find, let's say the requirement here is, I want to find each employee and I also want to find the manager name corresponding to each employee. This is what I want. Whatever I have shown here, this is what I want. I want to know that Nina's manager is Stephen K. I want to know that Alexander's manager is Lex. And I want to know Bruce's manager is Alexander. Every employee and their manager number I want to find. If I want to do that, I have to go back to the same table, right? And I have to connect back to the same table. Okay. So now in order to differentiate between this myEMP and this myEMP, we will give it an alias name, right? So I will call this myEMP as EMP. And this myEMP, I will call it as manager, right? Why am I calling it employee and manager? Because the thing that connects these two is manager ID and employee ID, right? So I will call this as EMP. I call this as manager. And now, now I have two tables. I know what is the common column, right? I have a table called EMP. I have a table called manager. I know what is the common column connecting these two. I can write a self-join, right? I can just say select employee ID, first name, last name, manager ID, and then first name and last name, right? So I will get 101, Meena Kochar, manager ID is 100, and manager name is Stephen K. Similarly, I will get 104, Bruce, manager ID is 103, and manager's name is Alexander Hunald. Right, so this is the output that I will get after I join these two tables. Right, so how do we write our select query? I can just say select whatever I want, right? So maybe select star, select, let me give it a star for the moment, right? From What are the two tables we are connecting? I'm connecting my EMP as EMP, right? Inner join or just to join my EMP as manager, right? On what is the join condition? These two columns, right? The manager ID from the employee table is the same as the employee ID from the MGR table, right? On EMP dot MGR ID is equal to MGR dot EMP ID, right? So this is all there is. All you need to do is identify the identify the common column. Then you can write your table. You can connect these two tables, not two tables. You can connect the same table to itself by connecting this common column. These two common columns you will connect and you will write a select. That's all you have to do. The only thing you need to do is identify the common columns here and give two tables. Rahul is asking, if we use self-join, then in the next manager ID, there is again an employee ID. I'm not sure I get the question. In the next manager ID, there is again an employee ID. Yeah. See, managers are also employees, right? If you think of a company, a manager is also an employee in that company. So that manager has an employee ID, but he also happens to be the manager of somebody, right? So the manager ID and the employee ID are the same, right? I hope I'm addressing the question that you raised. Hopefully. Yeah, okay, fine. Okay, so let's write this. Let's write this query and see if we get what we wanted to get. Right, so what we will do, let us select all these columns from the first my EMP table. Right, so I'll select the employee ID, then first name. First name, I will call it as EMP E first name, right? Just to know that this is coming from the EMP table, right? Then last, okay, I didn't give the, I should have given the prefix. I will say EMP dot employee ID, EMP dot first name, and I will call it EF name. And then from EMP again, I will choose the last name, right, as EL name. And then from the manager, right? So from these set of columns, I will just choose the first name and last name, right? So I will say MGR dot F name as F name, and or I could have called it, okay, fine, MGR first name or something, and then MGR dot last name as ML name, right? From my EMP as EMP join my EMP again, but now we call it MGR. And now what is our on condition? On, right? EMP dot MGR ID is equal to MGR dot EMP ID, right? So even if you read it in English, you can say you are connecting based on this condition, that is the employee's manager ID is equal to the manager's employee ID, right? And if you execute this, okay. Oh, okay. MGR dot first name and last name, right? I've given the column name wrongly. This should be MGR dot first underscore name and MGR dot last underscore name. Right. So let me clean this. Right. So this is what we wanted. So we wanted to see that these people, Michael, see, we know that Nina is reporting to Stephen. Right. So in addition, we also know Lex reports to Stephen, but there are other people who are reporting to Stephen. right? So these set of people are all reporting to this manager called Stephen King. How about this? These people are all reporting to Nina Kochar. Alexander only is reporting to Lex. But these people, these set of people are reporting to Alexander, right? So these people are reporting to Nancy. So this is what we wanted to see. For every employee in the company, right? So there were 106 records in the table, but we get 105 rows. Why are we getting 105? Because Stephen King happens to be the VP of the company and he's not reporting to any manager. Right? So Stephen King does not have a manager. Stephen King doesn't have a matching record in the table. Right? So that is why we are not getting Stephen King's manager, but for everyone else, right? All other employees are reporting to somebody or the other. So that is what we are seeing here, right? So this is the purpose of your self-join. When you see that there is a common column in the same table, and if to get that value, you have to loop back to the same table and get the result, right? And in those scenarios, you can go for a self-join. Once, see, writing the query itself is very simple, right? So once you identify what is the common column, you just need to give two alias names, right? And the manager ID from one table is equal to the employee ID from the other table, right? So this is how you can write a self-join where you connect the table to itself. Okay, spend some time over it, right? So try writing it on your own so that you get familiar with writing these queries. Okay, fine. So now, right. So this completes our topics on our topic on joins, right? So we have seen all the joins that are supported in MySQL. So the next topic that we need to look at is called database constraints, right? Again, a very important topic. So a database constraint. What is constraint? Please paste the query in chat. Okay. Let me copy this. And all right. So this is your self-join query. Yeah. Constraint is a limitation, right? You are correct. You can think of it as a restriction or a limitation or some kind of rule that is being applied, right? So there are different types of constraints. Yeah, constraints means a set of rules that is given to a particular data. That is correct. That is exactly correct, right? Okay, so we are looking at, we are going to look at what all constraints can be applied on your database tables and columns. So database constraints. So you can classify your constraints as domain constraints, right? And then you can call them, you have what is known as key constraint. And finally, you have something called the referential integrity constraint. Right, so this is the heart of your relational database management. Referential integrity constraint. So let's first look at domain constraints. They are very simple to understand. Right, so when you talk about domain constraints, you can say there are four types of domain constraints. So you have something called a unique constraint. You have something called a not null constraint. You have something called a check constraint. And finally, you have something called a default constraint. Right? So let's first look at the domain constraints and then we will come back to these two. So let's take a look at a table called our students table. Right? So in the students table, we said we have a student ID column. You have a student name column. Let's say there is an age column. and course, right? So we are saying that this will be integer. This will be character of 30 or varchar of 30, right? Age will be integer, and this is character of 30, right? Ideally, it should be a varchar, but yeah, I'm just writing it as char. I don't want to type a bigger name, right? So that's why. So this is our students table. So now the reason we have this ID column, right, is because we want to have a unique identification for every record in the table. For every student, we want a unique identifier, right? So that is why we have the student ID column. So we can ensure, or we need to ensure, that people don't give duplicate values here. It doesn't make sense if two students have the same ID, right? Two employees cannot have the same ID, or two citizens cannot have the same Aadhaar number or something, right? So we have to ensure that people don't accidentally enter duplicate values into this column. So what you can do, you can impose a unique constraint on this column. If you impose a unique constraint on this, it means you have to enter unique values into this. If you try to put one more value 1, you will not be allowed to put this record into this, right? It will say unique constraint is violated. Primary key, yeah, we will talk about primary key, but for the moment, let's talk about unique constraint. Right, unique constraint basically says you cannot have duplicate values in column. It can be any column, right? You can say student name has to be unique, although it doesn't make sense. I can have a unique constraint on the student name, which means I will not allow people with the same name to come and join the course, right? So I can apply unique on any column that I want. So the second constraint that you have here is the not null constraint. So let's say we impose the not null constraint on the student name column. So this basically means you have to give a value for the student name, right? If you try to put a null value into this, you will not be allowed to enter a null into this, right? If you say insert into table and you give null value for student, it will say column cannot be null, right? So you have to, you are constrained, and you definitely have to give a value for this particular column, right? So that is your not null constraint. Check constraint basically can be used to check the values that go into a column, right? So I can have a check constraint saying I won't take anybody whose age is less than 18, for example. So I will take only those people whose age is greater than 18. Right, so I can impose a check constraint to check this value. So if you try to insert somebody whose age is 16, your record will not be inserted, right? You will get a error saying check constraint is violated. If you try to give somebody whose age is more than that, if you enter somebody whose age is, let's say 21, for example, that record will be inserted, right? And course, of course, we don't have any constraints at the moment. So let's just keep it as such. Right. So now what we will do, let's drop the students table and we will recreate this by including these constraints on these columns, right? Manohar says null means not entering his name in the syntax. Yeah, that's right. Not entering his value in the syntax. Okay, so let me drop the students table and let me recreate it so that you see how you can add this these columns. By the way, you can have multiple constraints on the same column. You can say student name can be unique and not null, right? So you have to give unique values and you should avoid giving null values, right? So you can have unique and not null. You can have unique, not null, and check, right? So multiple conditions can be not null and default. Usually you will see not null and default constraints together, right? So these things you can just add as many constraints as you want on a single column. So let's see how to create it, right? So I will drop my students table, drop table students, students. students. So let me recreate this. Give me a moment. So we will say create table students, student ID integer. So we want this to have a unique constraint on it. I'll say unique, right? It need not be capitals. I'm just giving it in capitals just to highlight that it's a constraint, right? And then student name. Let me make it var of some 50. And I want this to be not null. Then we will create the age. I will make this as integer and I will give a check constraint, right? And I want to check that the age value is greater than 18. And then course, right? So I don't have any constraints on course, but this is of type var of, let's say 50 again, right? And close the bracket and the table is created, right? No, it's not case sensitive. I'm just giving it in capitals to highlight the constraint part, right? It's MySQL is not at all case sensitive. So now if you describe your students table, so you see UNI here, right? So that means this particular column needs to be unique. You cannot have duplicate values in the student ID column. Similarly, if you look at the student name, you can see null is no, right? So it cannot be null. You cannot have null values inside it, right? Check constraint won't be shown here, but we will see. Let's try to insert some records, right? And we'll try to violate some of these conditions and see whether the system is protesting or not, right? So I'll first insert values properly. I'll insert into students values. Let's say student ID 1, our John, and what is the next one? Age, right? So let's say he's 23 years old and he is learning MySQL. Right, so this record should go. What did I do? Value spelling. Okay, sorry. Values. Right. So now if I select star from students, everything is fine, right? I haven't made any mistakes here. I've just entered one record. So now what I will do, let's try to violate the unique constraint. How to create more than 200% table. That is, we have to enter 200. See, it is possible to load data from a CSV file into your table, right? So in the workbench, you have a table import wizard. You can use that. How to copy data from one table to another table. You can just say create table, new table as select something from something else. So let me finish this, right? And or maybe I'll just show you. You can say create table students 2 as select star from students. Right. So now if you select star from students 2, you will see the same value is available in students 2 also. Right. I think this is what you asked. Yeah, I think that's what you had asked. Can we repeat the insert? Yeah, already existing table. Okay, create. You can say insert into, if students 2 is already existing, you can say insert into students 2 as select star from some other table, provided all your columns and all match. Right. Okay, let's focus on the constraints. So we have inserted one record, right? Or not students too. I want students, right? So now what we will do, we'll try to violate the unique constraint, right? So I'll say insert into students values. I will put one only here, right? And instead of John, I will give Tom. But the other two values I'll keep the same, right? So 23 and MySQL, right? So now it says duplicate entry for student ID, SID, right? So although I have given duplicate values for age and course, it is not complaining. It's only complaining about student ID because we have given a unique constraint on the student ID column, right? So let's change this. If I change this to 2, it will go through, right? If I change student ID from 1 to 2, everything goes through, right? If you select star from students, you can see it is allowing duplicates in the age column. It is allowing duplicates in the course column. Only in the student ID column, it's not allowing, right? Because only for student ID column, we had given a unique constraint, right? So this is how your unique constraint works. So now coming to the not null, let's look at the check constraint, right? So what we will do, we will try to insert a record and we'll give an age less than 18, right? So I'll say insert into students values, student ID 3, Lara, and let's say she is only 16 years old, but she wants to learn analytics, right? So now it says this check constraint is violated. You're trying to enter a value less than 18, right? So we had a check constraint for that, and we have violated that condition, right? So let's change that. We will change it to 26, right? In which case your record goes through properly, right? So that is your check constraint. Now coming to not null constraint, right? So I will try to insert a null into the student name column. So what I will do, I will say insert into students values and 4, and instead of student's name, I'm just giving null, right? And then age value I will give, let's say it's 28, and the course also I know that is analytics, right? So now what it says column student name cannot be null, right? Because we have given a not null constraint on the student name. This is one way to enter a null value, right? So what is the other way of entering a null value? Instead of giving null, we can skip it. That is what V is saying. I don't know who is V, but V is saying we can skip it. Yes, you can skip it, right? So you can say, you can say I'm going to enter values only for student ID, age, and course, right? So how do we do that? We can say insert into students. I'm going to give value for student ID, age, and course, right? Values. What values are we giving? Let's say we give 5, and age is let's say 32, and course is MySQL, right? So this is another way to enter a null value into the student's ID column. But here the difference is instead of us specifically saying insert null, MySQL will try to put a null value into it because you have not mentioned the student name column, right? So now also you get an error, but if you see the error is very different. It's not saying student name cannot be null. Instead, it is saying the field student name does not have a default value. So why is it saying that? If you describe your table, right? So if you describe students, you see the default value here, right? So what this means is if somebody does not enter a value, right? If somebody doesn't specify value for a particular column like this, right? So here we didn't mention the student name column, right? So here it says if somebody doesn't mention student name, what should MySQL put in that place? So by default, the default value given is the null, right? So that is why MySQL tries to put null into the student name column, and here it is complaining. But this can be changed, right? I can change this null to, let's say, some Smith or something. So that means whenever somebody doesn't enter a value for a student name, enter Smith into it. Don't put null, right? By default, take Smith, right? It's there, right? Default value is there. But what is the default value that is given? The default value given is null. That is why MySQL is trying to put null into the column, right? So, okay, you're saying student name doesn't have a default value. See, null is not considered as a value. Null is basically, I don't know, right? So that's what it is saying. It doesn't have a default value. You only have null here. So if you change this, this error will go off, but this error will still be there, right? Because we are specifically saying put null into it. Whereas here we are asking MySQL to put whatever is there in the default column as the value for student name. I hope you understand the difference between these two. Right? So here we say put null into it, and MySQL will say I cannot put null. Here we are asking MySQL to put whatever is there in the default and take it and put it into the null column. Right? If you have given a value here, then it's not an issue. Right? MySQL will anyway put this. Otherwise, it will try to put null and you will still get an error. Right? So how to change default value, we will see. So that is our last constraint. Right? So that is our default constraint. So while creating the table also, you can specify the default, or after creating the table, you can use the alter table command, right? So I will use the alter table. I'll say alter table students, modify column. I have to give everything for student name, right? I have to give it as if I'm creating the student name for the first time. So I have to say student name, varchar of 50 and not null. And I will also say default Smith, right? So now if you check, if you describe your students table, you can see instead of null, the default value is Smith. So if you rerun this command, right, you will not get an error, right? Instead of student name, it will put a Smith into that, right? So let's try executing that command, right? So enter. And now it's going through, right? It's not complaining. And if you select star from students, you can see instead of putting null into this, this statement has put Smith into it, right? And it's not giving us any error. But if you specifically try to put null, you will still have that issue, right? If you try this command, you will still get the error saying column name, student name cannot be null, right? So these are the how to show databases. Just say show databases and that is it, right? All right, so these are your default values. Sorry, these are your domain constraints. Now going to the other two constraints, you have something called the key constraint and the referential integrity constraint, right? So your key constraint says, your key constraint says when you're creating a table, right? So whenever you create a new table, there should be at least one column. There should be at least one column that can uniquely identify a record. So these are basically, okay, identify a record, right? So these two constraints are unlike these constraints. These are kind of guidelines as to how to create our tables, right? So these two are tell us how to choose column names, and it's a kind of a guideline more than a right, calling it a constraint here. It's a guideline as to how to create a table. So when you're creating a table, you should try to have at least one column inside it which can uniquely identify a record. So what do we mean by uniquely identifying a record? So whenever you say select, right? So if you're selecting star from students, for example, right? Based on this particular column, let's say student ID, right? So select star from students where student ID is equal to 1. So this should return only one record. That is what we mean by uniquely identifying a record. So multiple students cannot have the same ID. There should be at least one column like this. Otherwise, if you have duplicate values, then it will not be possible for you to separate the two records. Right? It will be very difficult for you to, you cannot separate anything. You cannot separate the two records at all, right? If you have duplicates. So when you're creating tables, you should always try to have at least one column which you can use to uniquely identify a record in the table. So this constraint is usually implemented using what is known as the primary key concept. So this is implemented using a primary key. That is, whenever you are creating a table, right, make sure that there is one column, at least one column, which can act as a primary key. The job of the primary key is to uniquely identify a record. So by definition, right, a primary key should be unique and not null. Right, so you don't have to specifically say unique and not null. Whenever you say a particular column is a primary key, it is understood that that particular key is both unique and not null. That is, if you have an ID column, right, so you cannot have null value as your ID, and there cannot be duplicate values in the ID. Right, so this is understood. Krishna, you have a question? If you have, go ahead and type it. Okay, meanwhile, let me, Krishna, if you have a question, you can type it, okay? Okay, so this is your key constraint. The next constraint, the referential, okay, there will be another key, say secondary key, foreign key. Yeah, that is what we are going to look at. So the next constraint basically tells you how to define relationship between different tables. Right, so till now we have created standalone tables, but how do we define the relationship between them? Right. So if you remember in the very first class when we were talking about DBMSs and relational DBMSs, we had specified that if you're creating a table called students, right, so it should only contain attributes which are specific to students. You can have student ID, you can have student name, you can have age, right? You can have course. But see, if you have something like duration, fee, and all, this is not the right. This is not the right way to create a table, because see, student ID is a property of student. Student name is a property of student. Age and course are properties of students. But duration is a property of course, and fee is also a property of course. So if you create a table like this, right, so what will be the problem here? You will end up having a lot of redundant data. You will end up repeating a lot of data unnecessarily, right, if this is how you create your table. So what will happen if you're inserting records? You will have student ID 1, for example. Student ID 1, John, 25. He is taking MySQL, 2 weeks, duration, and $100, for example. So if you have Mary taking the same course, right? So she is 20. She is also taking MySQL, 2 weeks, $100. If George is also learning MySQL, you will have George, 25, MySQL, 2 weeks, and $100. So you can see this MySQL 2 weeks, $100 is getting repeated multiple times. Right? If there are 1,000 records, 1,000 people learning MySQL, for all of them, we will be repeating the same. And we know how much space it is going to take up in memory, right? So instead, what we should do, we should create a separate table called course, right? Instead of clubbing this here, you should have a separate table called courses, right? You will create a separate table called course. And here you will have a course ID, right? By the way, which is the primary key here? In this case, I will define the student ID as the primary key in this table. And in the course table, I will create course ID as the primary key. Right? So this will be unique and not null, and it will be uniquely used to identify a record, identify a course, right? So course ID, course name. What else? Let's say duration and fee, right? So here, let's say course ID is C1, course name is MySQL, duration is 2 weeks, and fee is $100. And then you will have details about the second course, right? So probably analytics, 6 weeks, and $500, right? And course 3 might be data science, 6 months, and $1,000, for example, right? So this is what your course table contains. So here you see there are no redundancies, right? You are just you are only having columns inside it, which are properties of this entity called course. What will you have in this table? In this table, you will have, see, this person is learning C1. This person is also learning course 1. This person is learning course 1. Right. So now, if we are saving space here, right? But now we need to say, if you want to know what is course 1, you have to go to some other table. Right? If you want to know what is course 1, what is John learning, you have to go to the course table. So this column called course, let me call it course ID, right? The column called course ID in the students table is actually pointing to the primary key in a foreign table. Foreign table in the sense something in a different table. So this key is called the foreign key. The course ID column in the students table is a foreign key because this actually refers to the primary key in a different table, right? So this is how we define the relationship between students and course. So there might be another student, right? So student 4, let's say Pete, who's 34 years old, and he is learning course 2, right? So he is learning analytics. So what is referential integrity constraint here? The constraint here is in this key called the foreign, in this foreign key column, you can only have values which are there in the primary key of the course table, right? So by the way, this table, the table which contains the foreign key is called the child table. The table to which the foreign key is pointing, that is called the parent table, right? So when you're putting values in the child table, in the foreign key column, right, you should make sure that corresponding value is available in the parent table. That is, a parent record should be available for these values in the parent table. If you don't have it, let's say you try to insert a value like 5, George, not George, George is already there. Somebody called Tom, right, who's 18 years old, and he is learning C7. So this is not allowed. If you try to enter a record like this, it will say the referential integrity is violated. You are trying to put a value into the child table for which there is no parent record here. So this is an orphan record. There is no corresponding parent record in the parent table. Child table accepts null. Yeah, it accepts null. You can have null values, but you cannot put a value which is not there in this table, right? So you cannot put C7 or anything. So this is an orphan table and orphan record, and orphan records are not allowed when you're creating this kind of primary key foreign key relationship, right? By the way, a particular table can have multiple foreign keys, right? It's not like it can have only one foreign key. Let's say you have another table called department here. So if you have a table called department, let's say you have department ID, the name of the department, the location of the department, and other details, right? So if you have a department table like this, and let's say department ID 10 is statistics department in Chennai or something, and department 20 is computer science department in Bangalore, something like this, right? So you can have a column here called department ID. You can have a column called department ID, and this department ID will be, this is also a foreign key, right? So this table, this column is also a foreign key. So you can have any number of foreign keys. So this is also a foreign key, but this foreign key is pointing to not this table, right? But this is pointing to this, the primary key in the department table. What is the primary key in this? Department ID should be the primary key here, right? So this is the primary key in the department table. So this is a foreign key. So this is also a parent to this child table, right? A parent table can be a child of some other table, right? So you can have a foreign key here, which is referring to course, or you can have a foreign key here, which is referring to some faculty table or something, right? So maybe you have a table called faculties here, right? So faculty, you have faculty ID, faculty name, and the subject they are taking, and details about the faculties, right? And here you can have a reference to the faculty ID, right? So then this will become a foreign key, and this will be pointing to the faculty ID in the faculty table, right? So this table is a parent to students, but this happens to be a child for faculty, right? Because this is the table that has the foreign key pointing to this faculty table. For this table, this is the child. For this table, this is the parent. Right? So like this, you can define any number of any kind of complex relationships. Right? So student table can be linked to course, and it can also be linked to department. Department can be linked to faculty, right? Faculty might link back to course, right? All kind of relationships you can create depending upon how you want to organize your data. Right? So this is the strength of your relational database. This is the heart of your relational database. Defining the relationship between two tables by specifying the primary key and foreign key. So the main thing that you need to remember is the foreign key can only point to the primary key of some other table, and the values in the foreign key has to come from the values in the primary key of the parent table, right? You cannot have orphan records. Is that fine? Right? So this is what we mean by, this is how you can define the relationship between different tables. So let me write it again here, right? So let's say we have created the students table. We made the student ID as the primary key, student name, age, and course ID, right? And we have defined the student ID as the primary key, and we have defined course ID as the foreign key, right? And we are referring to the course table. Let's just look at a simple relationship, right? So course table has the course ID and course name, duration, right, and fee. Again, what is the primary key here? The course ID is the primary key here, right? And this is the parent. Foreign key means Rahul is asking, foreign key means address the next table of the primary key. Address in the sense it will be pointing to the value in this will be actually referring to the primary key in some other table, right? So that's why we call it a foreign key. It's pointing to a foreign table, right? So this is how it is. Right, so these are the two tables that we have. And we had entered some values into it. Right, so let's say the course table has what all did we have? C1, C2, C3. We had MySQL, analytics, and data science. 2 weeks, 6 weeks, and 6 months, and $100, $500, and $1,000. And when we put values into the student ID column, right, so we made sure that we are not violating any condition, right? So we have Tom, 25, he is taking C1. Mary, 20, is also learning C1. Let's say Pete, 32, is learning C2, right? So we have made sure that we are not violating any condition. But let's say after we do this, after we enter these values, what will happen if somebody deletes a record from this? What if somebody deletes a record from the parent table? Now C2 becomes an orphan, right? And orphan records are not allowed in the foreign key, right? So because of this, you are normally not allowed to delete a record from the parent table. If, okay, let me write it. This is parent and this is child. Okay, don't forget that. So normally you will not be allowed to delete a record from the parent table if there is a child record pointing to it, right? Similarly, what will happen if somebody updates this field? Let's say somebody changed the C1 to C10. Again, you're left with orphan records, right? Because when we entered, it was there. So it allowed us to enter it. But afterwards, if somebody does an update, right? So you are still left with orphan records. So normally update is also not allowed if there is a child record pointing to the parent record, right? But this could be a kind of, what do you say, a restriction, right? Because if you have tables that are maintained for years together, right? If you have a long running application, there might be cases where you want to clean up this table or you might want to change this, right? So in this case, what we have to do is when you create the child table, the child has to give permission for the parent to be deleted, or the child has to give permission for the parent to be updated. So how does the child do that? While creating child table, you can say on delete cascade. What do we mean by cascading? Cascading is like flowing down, or basically what we means is whatever change you make here, you cascade that change to the child also. That means if you're deleting a record from here, automatically delete a record, the corresponding records from the child table. So now you don't have any orphans, right? You delete from here, you delete corresponding records from here. No orphans, problem solved, right? So similarly, if you want to do an update also, the child has to give permission. So child has to say on update cascade, right? So that means if you're making a change here, if you're making this C10, make this also C10. Now again, you don't have any orphan records, right? But this is totally up to the child table. When you're creating the child table, you can choose to allow deletions from the parent. You can also choose to allow updates to the parent. If you do, is it Mukesh? Okay. Is it required to have same foreign key name and child and parent? No, it's not. It's not. That is not a requirement. I can call the CID, right? And the other one can be called course ID. There is no need for the same name. So this can be called CID if you want. But while defining the table, we will say this column is actually pointing to this column in this table, right? So that is all you need to do. Okay. So this is your on delete cascade and on update cascade, right? So let me do something. There is a couple of tables on your database, right? So you have a table called authors. You have a table called authors. You will say select star from authors, right? So you have 10 or 11, 11 records in authors, right? And then, sorry, 9 records in authors. And then we have, if you select star from books, there are around 14 records here. And if you see, can you tell me which is the parent table and which is the child? By the way, which is the primary key in this table, authors table? What will be the primary key? Yeah, author ID. Author ID will be the primary key inside this. How about books table? What is the primary key? The book ID will be the primary key, right? And which is the foreign key here? Author ID. Yeah, that's right. So this is the foreign key. So this key is actually pointing to the author ID column in the authors table, right? Author ID name. And this is the foreign key. It is pointing to this. So which is the child and which is the parent now? Which is child and which is parent? Author is the parent. Yeah, that's right. Author is the parent and child is books, right? So this is parent and this is the child, right? So what I will do, I will drop these two tables, right? And I will recreate it so that we can see what is the syntax for creating these tables, right? So let me, okay, by the way, one more thing. What will happen if I try to drop the authors table? Can I drop authors now? Yeah, it's not possible because if you drop it, there are a lot of records inside the books table, which is going to be orphans, right? So you cannot drop the authors table because what will happen if you drop this table, then you don't have any parent record for this. The table itself is gone, right? So it will not allow you to drop the parent table. So when you're creating the tables, right? So when you're creating tables, you have to create the parent first and then create the child. When you're dropping the tables, right, you have to drop the child first and then you have to drop the parent, right? So this is the order that you have to do, right? So let me first, okay, let me try to drop authors and let's see what happens, right? I'll try to drop the parent table. So if I say drop table authors, you can see you cannot drop authors because it's being referenced by a foreign key constraint, right? So there is a foreign key in the books table, which is referring to this authors table, right? So you are not allowed to drop it. So let's first drop the child table. So I'll say drop table books, and now it will allow me to drop the table. Now let me drop authors, right? So now both tables are gone. So let's recreate it, right? So how do I create the table? Let me clean this, right? So we'll create a table called authors, right? So create table authors values. Sorry, what am I doing? Authors author ID integer. The spelling correct? Author ID. Okay. Integer and I want this to be the primary key. So I just say primary key, right? And then what was the next column? We had name column. Let's make it varchar of 255. Okay, we had only 2 columns in our uh, Rahul is asking, can we do undo option in MySQL? Yes, you can do that, but there needs to be some conditions to be satisfied. If possible, I'll show you. If time permits, at the end of the session, I'll show you how to do an undo, right? How we can do a rollback, if time permits. It's not part of what is planned. All right. So we have, let's create this table, right? So now table authors is created. Let's describe authors. So here you can see author ID is the primary key. Null value not allowed, right? Because when you say some column is primary key, by default, it has to be unique and not null, right? So null is not allowed. And because it's a primary key, it's also unique, right? So now we will write, let's create the child table and I will write it in a notepad, right? I already have this. So I'll write it in this notepad so that if at all we make a mistake, we can come back and correct it, right? So here we will say create table. Can you see it, or is it too small? Are you able to see what I'm typing? Okay, fine. All right. So I'll say create table. Okay, fine. Thank you. So we'll say create table books, right? So we have the book ID, which is the primary key. Book ID integer. So this is our primary key. And then we have the title of the book, right? So title, let's say varchar of 255. And then we have the author ID column. Sorry, author ID integer, right? Now give a comma, and then we will say the foreign key in this table is actually the author ID column, right? I can call this AID also. It need not be the same name, right? So maybe I will call this AID, right? It need not match. Zoom a little. I am not able to zoom it, so that is a problem, right? Okay. So foreign key is the author ID, and this, sorry, I changed it to AID, right? So the AID column in this table is the foreign key, and this references. What does it refer? It refers the author ID column in the authors table, right? So this is how you can define your foreign key. Now we want to allow the parent table to be updated and deleted. So how do we say that? While creating the child table, we have to specify, right? So we will say on delete cascade, right? So this is purely optional. If you want to allow delete, you will say on delete cascade. If you want to allow update also, you will say on update cascade, right? And that is it. See, if you notice, there is no, okay, there is no comma or anything here, right? So all of this is one foreign key, right? So remember, you can have multiple foreign keys, right? So let's say you have another foreign key called department. It doesn't make sense, but still, if you have another foreign key called, if you have something called department ID here, right? So let's say you have a column called department. References. Okay. So here, if you have a column called department ID, right, and let's say this is pointing to the department column and the department ID in some other table, then again you can see foreign key DID, right, actually references the department table department ID column, right? So DEPT table DID column, right? And here also you can say whether you want to allow records from the department table to be deleted or updated. You can say on delete cascade here and on update cascade, right? So this is how you can specify multiple foreign keys. Anyway, let me remove this. We don't have multiple foreign keys here. So let me remove this also. And DID also is not there, right? So once you start your foreign key, there are no commas anywhere. The whole thing is one foreign key definition. Okay, so this is how we can create our books table, right? So let's hope everything is fine and we haven't made any mistakes. What's this? Okay, let me copy and paste it here. Right. Now the table is created, right? And if you describe your books table, you can see the book ID is a primary key, and MUL basically refers to the foreign key, right? Although see what it means is you can have multiple values of the same foreign key inside this. So usually, so this is what you will see. Whenever you see MUL, you can be sure that it's a foreign key and it is pointing to some other table, right? Okay, so now I have created these two tables. Let me take values from the practice tables and let me insert records into that. Right, so I don't want to type. So I will insert into authors all these values. And I will insert into books. Okay. Right, so this is it. Insert into authors and insert into books. And if you select star from authors, you have 8 records. And if you select star from books, you have the 14 records back, right? So now let us check out our on delete cascade. So what did we do? We said if you delete a record from this table, the corresponding record should get deleted from the child table, right? So let's try deleting the author from the authors table. So I'll say delete from authors where author ID or the author ID, author ID is equal to 1. Right. So now it says 1 record deleted. So if you check your authors table, author ID 1 is gone. Right. So now if you look in the books table, you will see all records corresponding to author ID 1 is gone. Right. So these 4 records are gone. And why did that happen? It's because we have specified on delete cascade, right? Any delete that you do on the parent, cascade that change onto the child also. So it has automatically removed the records from the child and we don't have any orphan records, right? Let's check out our on update cascade. Let's update the author ID column here. I will change this to 80, right? Instead of 8, I'll change it to 80. Right, so let's say update authors, set the value of author ID is equal to 80, where author ID is equal to 8. Right. So if you check the authors table, you can see this has become 80. Right now, if you look in the books table, you can see correspondingly, right? So wherever you had 8 here, right? So this has been changed to 80 here, right? So our on update cascade is also working fine, right? So this is how you can define the relationship between multiple tables using your foreign key and primary key and foreign key. Okay, so we know what is a primary key, what is a foreign key, and what is a parent table, what is a child table, and we know what we mean by the referential integrity constraint, right? You can only have values in the foreign key, which is taken from the values from the primary key. Anything other than this is not allowed in this table, right? So that is your referential integrity constraint. So now coming to go to the update query. Okay, this is the update. Okay, fine. So now coming to primary key, right? So we have specified that the primary key has to be unique and not null. So when multiple people, let's say if there are many people updating the same table, right? So this could lead to some problems, right? So we talked about the patient table, right? So let's say the patient table is being updated by multiple people, right? So patient ID, patient name, we had the date of birth and time of admission and all, right? So if you go to a hospital, right, so you will see there will be multiple counters and people will be sitting behind these counters, and people will be waiting in front of these counters to get get admitted to the hospital, right? So let's say the first person enters patient ID 1 and the other details. When the second person is entering the record, right, so entering a new value, they have to see what was the last value entered into the table, right? And then they have to increment it, and then they have to put 2 into it. Now again, when this person is entering a value, this person also should see what was the last value entered, right? And then they have to put 3 into it. But this is kind of error prone, right? It's possible that when both people looked up, they found 3 as the last value, and they will both try to insert 4 into it, right? Which could lead to failure, right? It will give you duplicate values and all that. So in order to avoid this kind of confusion, right? So you have what is known as a sequence object, right? A sequence object, the only job of a sequence object is to create a sequence of numbers. It will create 1, 2, 3 like that, right? So this is all a sequence object is expected to do. So what we will do is you can create a sequence object and you can attach it to the primary key of a table. The restriction here is sequence can only be attached to the primary key. Only attach to the primary key. You cannot attach a sequence to any other key, any other column, right? So you create a sequence and attach it to the primary key. So now it becomes the job of the sequence object to give next values for the primary key column. These people will only enter the value for name, date of birth, and time of admission. Sequence will give 5 here, right? And it will remember that the 5 was the last value entered. And then when this person enters the next record, sequence remembers that the last value was 5. It generates 6. It will put 6 into this, and it will remember 6 was the last value that was generated. Again, when this person enters the next record, sequence remembers 6 was the last value generated. So it will generate 7 and put 7 into it. And it will remember that 7 was the last value generated, right? So this is the job of your sequence object. So in the case of MySQL, when you talk about other databases like Oracle and all, you can create a sequence explicitly. What do we mean by explicit? We specifically say create sequence, MySequence, and then you can attach it to the primary key of a particular table, right? So this is explicit creation of a sequence. Is it complicated? Are you finding it difficult to follow? Sadiq, where is the problem here? Okay. Sequence is complicated. Okay. See, the only thing we are saying in the case of sequence object is we don't have to specify the value for primary key, right? We only specify value for the name, whatever other things are there, DOB and time of admission. So when you're inserting a record into this, the sequence object, which is attached to the primary key, will generate number 1. When the next record is inserted into the table, sequence will generate number 2. And it will remember number 2 was generated and put into it. When the third record is inserted, sequence will remember 2. It will increment it by 1, put 3 here, and it will remember that 3 was the last value that was inserted. Right? So the sequence takes care of entering values into the primary key. You don't have to specify it. And because the sequence keeps generating next numbers, it will never have duplicate values and it will never have null values in this column. Right? Okay. So when it comes to other databases like Oracle, you can specifically create a sequence. But in the case of MySQL, right, you cannot explicitly create it. You don't have an option to create a sequence explicitly. Instead, you will implicitly create it by specifying auto increment. Right? So when you're creating a primary key, you will also say auto increment. If you say auto increment, this will automatically create a sequence object, and this object will take care of entering values for the primary key. Let's look at an example, right? So let's create a table with the primary key and we will add auto increment also to it, right? So let me create a table called my tab. I hope there are no my tabs here. There is no my tab. So let me create a table. So I'll say create table my tab. It has ID integer and this is my primary key. Right, so I don't have to make it capitals, but primary key, right? And I will also say auto underscore increment. Remember, I can have auto increment only with the primary key. Increment. Okay. Okay. So I have specified auto increment here. And let me have 2 more columns. I'll have a column called name. And let's say it's varchar of some 20. And then I have a column called age, which is integer, right? So this is my table. So if you describe my tab, you see it says auto increment. That is, this particular column will be populated by your sequence object. You don't have to worry about it, right? And obviously this is a primary key and you cannot have null values. So now I will only insert values for name and age. The sequence will take care of inserting values into it, right? So I'll say insert into my tab. I am going to give values only for name and age, right? Oops, age, values. Let's say I enter Tom and he is 23 years old. Right, so now if you select star from my tab, you can see automatically the ID column has got a value 1 into it. Yeah, Rahul, that is what it means. We don't have to insert value for the primary key. Let's insert 2 records at the same time and see what happens. Right, so we'll insert into my tab name and age values. Let's say John, 18 years. And let's insert 1 more record for Jim. And he is 34 years. Right. So I'm inserting 2 records at the same time. So now if you select star from my tab, you can see automatically 2 and 3 has been assigned to John and Jim. Right. So it is giving next values for the primary key. So this ensures there is no duplicate and there is no null value. Right. So let me delete everything from the table. If I say delete from my tab, all records are gone, right? Now if I reinsert some records, right? If we use like this, what happens? Insert into my tab values. See if you see what Rahul is asking, insert into my tab values Tom and 23. If you give it like this, you will get an error saying the number of columns does not match the number of rows. Sorry, number of columns does not match the number of values that you have given. Right? If you have to say values, then you have to give value for all 3 columns. Otherwise, you have to say only for these columns, I'm going to enter values. Okay, so now I have removed all the records from the table, right? So our table is empty. So now if I try to insert a record, let me insert Tom into this. What will be this ID that is given? What will be the ID for Tom? Okay, so, 1. Okay, actually, it will not be 1, right? It will continue from where it left off, right? So why is it continuing from where it left off? Because we have a table called my tab, right? We have columns, rows inside it, ID, name, and age, right? We have 1 Tom 25, 2 John 35, and all that. So we have created a sequence object and we have attached it to the table. So when you say delete from my tab, we are not touching anything about the table. Right? So here it will remember that 2 was the last value that was generated. Now when you say delete, right, only these records are getting removed from the table. The table itself is untouched. So when you insert the next record, let's say George or Pete or somebody, it will remember that 2 was the last value that was inserted. So it will give 3, and then it will remember that 3 was the last value that was inserted. Remember our example. Sorry. Remember the example of our house and people, right? So the house itself is untouched. So any objects that are there on the house will also be untouched, right? So sequence has been created on top of the house. So only we are asking the people to leave the house. So therefore this is untouched. What happens if I say truncate, right? So let us say, I'll say truncate students or truncate my tab. Again, I'm left with an empty table, right? Now, if I say insert into this Tom or somebody else, let's say these 2 people, right? And if you select star from my tab, you see it is restarting from 1 and 2, right? It will restart from 1 and 2, right? Because it's dropping, it's demolishing the house itself, right? So the table itself is dropped. So all the objects associated with it also will get dropped. And when you recreate the table, again, a new sequence object is getting created and it will start counting from 1 onwards. Right? So this is how you can use auto increment to populate the primary key in your table. Okay. Right. So this brings us to the last topic in our session, which is that of views. Right? What is a database view? View is also another object that you can create. Just like you can create a table in your database, you can create a sequence object in your database. You can also create a view in your database. So view is usually defined as a window on the table or window on the data. Right? So the main advantage of view is it does not need memory, does not use memory, right? So what do we mean by this? So let's say we have our myEMP table. Select star from myEMP and let me limit it to some 10 records, right? So here we have seen, so let's say I'm not interested in all these columns all the time, right? I am only interested in, let's say I want to see employee ID, the first name, last name, right? And I want to see their job ID and salary, right? So it's like I've created a window on this data, and I want to look at only this part of the data, right? Yeah, it's like a virtual table. Yes. Right. So I want to look at only this part of the data. Obviously, you can do a select, right? So you can say select employee ID, first name, last name, and job ID and salary, right? But if you do that, so let's say I want to see select EMP ID, first name, last name, and salary, and job ID and salary. It's a job ID, comma, salary from my EMP. Right? So this is fine. This will show you only this part of the data. But if this is something that you keep using all the time, right? Most of the time, this is all you are interested in. Instead of typing this query all the time, right? You can create a view to represent this, right? So I can say create view, my view as select all of this, right? So maybe let me copy this, the same select query, right? So select this, right? So now instead of typing this big query, I can just say select star from my view. Right, so I get the same result. Right, I get to see only the employee ID, first name, last name. Right, so this is usually called a virtual table because it does not take up memory. Right, so don't think of it like you have 10 columns in one table, right? And when you create a view, you are taking few columns from this and putting it in a different place and storing the data inside it, right? So this is not correct, right? So a view does not take up any space. A view is only the best way to think of a view is like a named select, right? So it's like you are associating a name with a select query. So whenever you say select star from my view, whenever you say select star from my view, this is the query that is getting fired at the backend. Right? So whenever you say select star from my view, the actual query that is getting run is this one. Right? You are just associating this name my view with this select. So tomorrow, if you add a few more records into the my EMP table, it will be available in my view also. Right? Because what is the query that is being fired? We are just selecting this from the my EMP table. Right? It will only store the query, right? It will not store the data. The only thing that my view needs to store is what is the query associated with this view. Right? So this is the only thing that is. So the best way to think of a view is as a named select, a select which has been given a name. Right? So this may not seem like a big deal here because it's a simple query. It is okay to type it multiple times, probably not an issue. But what if you have some complex query like your joins and all? You remember the left join that we wrote yesterday? Do you remember that? We had movies table from movies, and we had a members table, right? And we had a left join. We have to, if you write it properly, you have to write it with some alias names, your prefixes and all, right? So did we see if null? How to use if null? If null of something, last name. Did we see this? You don't remember? Okay, we didn't see. Okay, so here let's write the join first, right? So we can select movie.id, movie.title, and then members dot first name, members dot last name from movies as MV, left join members as on movie.id is equal to movie id, right? So this is how you will rewrite it using your joins and all, right? But here, let's say I don't like to see these null values. I don't want to see these huge null values. Yeah. Right. So instead, what I want to see is, see if there is a null value in the first name column, I want to see a dash there, right? So that it will be cleaner. So how do I say that? Let me copy this, right? And I will type it here so that I don't have to scroll back and forth. Right. So let me just paste it here. So we are saying select. See here, what I want to say is, if the value of first name happens to be a null value, put a dash there, right? So how do I say that? I'll say if null dot first name, right? Put a null there. Sorry, put a dash there. Don't type a big null. And this I will give a alias name, right? Otherwise the column name will look horrible. So I'll save as first name, and this one, right? So last name also, I want to say if the last name column happens to be null, right? Replace it with the dash, and let's have an alias name, right? L name. Sorry, L name, right? So this is my full query. So let me type it. So let me copy and paste it here. So now, where is the problem? Has L name. Okay. If okay, if null, I forgot to say null. If null this, let me paste it. So you can see this is much cleaner than this one, right? So I can see where there is no value, right? So let's say this is a query that I'm always typing. I don't want to every time sit and type all this, then format it, give it an alias name and all that. Instead, I can just create a view on it, right? So I can just say create view. Let me call it rentals as this, right? So once you create a view like this, all I have to say is, yeah. So once I create a view, I just need to say select star from rentals, and I will get the same result, right? So no need to type all this full query. So you can see how convenient this is, right? So this is mainly a convenience thing, right? If there is a query that you're typing again and again, right, you can create a view on it. And once you create a view, right, so that is one reason. One reason it makes you feel it is easier to type these commands. The other thing is you can restrict access to certain parts of your table, right? So if you look at your myEMP table, from myEMP, let me limit it to some 15 records. See here you have this table contains details about people from all the departments, right? So if you want, what you can do, you can create a view, right? So let's say we create view department 60 as select star from DP, from myEMP, where DPID is equal to 60. Where is the mistake? Create view as select star from myEMP. Oh, I already have that. Okay, drop view P60. Right. Now let me recreate it. Create view department 60 as select star from this. Right. So now if you say select star from DEP60, you see only those records which belong to department 60. Right. So if you are a database admin, what you can do is you can create multiple views like this. And then you can give access to people in department 60 to this particular view only. Right. So they will be able to see all the records belonging to people in their department. They will not have access to, they cannot see data belonging to people in department 100 or department 30 or anything. Right. So you can create multiple such views and give permission only to access to this view to these people. So they need not even know that there is a table called myEMP at the backend. Right. So this is another advantage that you can limit access. Yeah, you can use where condition. You can use any condition in creating your. You can write any select. Right. So any select can be written, and you can create a view based on that. Okay. So this is one more advantage. If you see, once you create a table, once you create a view, it is treated exactly like a table, right? So somebody looking at this query will not be able to say whether department 60 is a table or a view, right? Because this is exactly being treated like a table. In fact, if you say show tables, right, you will see all the record, all the views also. Rentals is a view. There is a my view, right? All these are views that we have created. Department 60 is a view, right? But it is shown as a table only, right? So there is once a view is created, it is treated very much like a table, which means you will be able to insert records through the view. You will be able to update, delete, all those you can do through the view. But the main thing you need to remember is, although you are inserting through the view, the actual data goes into the backend only, right? So remember, we are considering view to be a window on the data. So let's say you have a room and you have a window. Anything that you insert through the window will eventually land up in the room only, right? The window does not store any data. Similarly, anything that you insert through the view will land up on the backend table only, right? Because the view does not store any data. Right, so let's try to create a small view and we'll try to insert some records into it, right? So we have a very small table called our authors table. So what we will do is we'll create a view, a view as select star from authors. Let's say where author ID is less than 10. Right, I'm creating this view. So now if you select star from authors, what do we see? We see these records, 7 rows are there, right? But if you select star from a view, how many records will you see? You can only see 6 rows, right? Because the view is created based on this condition that the author ID has to be less than 10. So it will only select those records where the author ID is less than 10, right? So let me try to insert a record through this. So I can say insert into a view values. Let's say 11 and John. Right. Now it's getting inserted. But if you see select star from a view, you are not able to see this record. Why? Because a view is not going to select that record because it violates this condition, right? View will only show you those records which satisfy this condition. But if you look at the backend table, if you select star from authors, you will see whatever we inserted through the view has actually landed up in the backend table, right? But what you have done here may not be a good thing. because remember our department 60. Why did we create department 60? Because we wanted to restrict access to only people in department 60 can only see people details about people in department 60. But although they cannot see the values for other departments, according to this, what we are seeing here, it is possible that they can insert records belonging to 100, right? Even if it violates the condition based on which the department was created, sorry, based on which the view was created, you are still able to insert records which violates this condition, right? So that means I can put values where department ID is not equal to 60 also, right? So I can enter values for department 100. I can delete records belonging to department 100. I can update values from department 100 or other departments, right? So this may not be a good thing. So if you want to restrict, right, if you want to restrict access and you want to say that you can only insert, update and delete also, provided you meet the condition based on which the view was created, right? So you can insert records as long as department ID is 60. You can update records as long as this condition is satisfied. You can delete records as long as this condition is satisfied. Anything other than that, you should not be allowed to do, right? So that means here, if I try to insert something like 12 and into the table through the view, it should stop me from doing that, right? Because I am inserting something which violates the condition based on which the view was created. I can do insert, update and delete as long as the author ID is less than 10. Anything else I should not be allowed to modify through the view, right? So how do you do that? When you're creating the view, you specify what is known as the with check option. Let me drop this view, right? I'll drop view, a view, and then I will recreate it. I will use the same command to create, right? Only thing is I will also specify with check option, right? So now if I try to insert something which violates this condition, I will not be allowed to insert, right? If I try to insert, let's say John Snow, whose author ID is 12, this will not allow me to do, right? Because I am trying to insert something through the view which violates the condition based on which the view was created, right? So let me try this. It says check option failed, right? But if I change this to something less than 10, right? Let's say I make it 1, right? Because I don't have a 1 here. So if I do something like this, if I change this to 1, it will allow me to insert, right? Because now I'm obeying this condition. I'm inserting, but I'm also taking care that I'm not violating this condition, right? So now if you check the view, if you select star from a view, select star from a view, you will be able to see the record that you inserted. If you select from the table also, you will be able to see the record that you have inserted, right? So this is it about your views, right? Yeah, it can be shown in authors. Yeah. Is this fine? Right. So this is what your view is all about. You can treat it exactly like a table, right? You can insert, update and delete through that. And yeah. Right. So that brings us to the end of our session, right? So whatever we had planned to cover in 4 days, we have covered. The initial basics we have covered, right? So hopefully you found the session useful, right? And yeah, thanks, Rahul. Please do practice. Don't let this go waste, right? Whatever you have learned, please practice. It's really very important skill for you. Fine. Okay. Yeah, thank you. Thanks a lot, Ashutosh. TCL is not part of this session, right? So we are not covering that. Undo option, okay, maybe 2 minutes, but okay, let me quickly tell you how to do undo, right? So actually in your database, there is something called the auto commit option. So auto commit basically means whenever you are inserting record in, whenever you are doing an insert, update or delete, right, it will get committed immediately. That is, it will get saved immediately. So once something is saved, you cannot do an undo on it. But if it is not saved, you can do an undo, right? So I'm not going much into detail, but by default, the auto commit is turned on. So that means any insert, update and delete you do will get saved immediately, right? So let me insert a record into our students table. Select star from students. Right, so let me insert a record. So I will insert into students values 6 King 67 and MySQL. Right. So this record has got inserted and it has automatically got committed. Right, it has got saved into the table. So now I cannot do an undo. How do you do undo? You can say rollback. Right, so rollback means it should undo whatever you have done, but you cannot do it now because your auto commit is turned on. You can turn it off, right? So you can say set auto commit equal to 0, right? So this means I am turning off auto commit. So now we have to say commit, only then it will get saved. So if you don't say commit, you will be able to roll it back, right? So let's insert one more record into it. So I will not type anything else. I will just change the student ID as 7, right? And now if you select star from students, you see 7 has been inserted. But now it has not been saved. I've only inserted into it. I have not committed the change. So now if I say roll back, right, I can see 7 is gone, right? I have done an undo of the insert, right? So, so if you turn the auto commit off, it's your responsibility to commit it, right? So let me insert it once again. I'll insert 7 once again, and now I will say commit. So that means I have inserted and I have saved it. I made it permanent, right? So now I cannot roll this back. I cannot say roll back, right? So this will not get rolled back because I've committed that change. So commit is to make a change permanent. Rollback is to undo a change, right? And this you can do as long as auto commit is turned off on your system. If it is turned on, every time you do an insert, update or delete, the server itself will issue a commit command and make it permanent. Okay. So that is a very fast introduction to your rollback. And yeah, Lokesh, thank you. Only DML can be rolled back. DDL commands cannot be rolled back. Right. Right. Atishay, I think you can contact the administrators for the practice tables, right? So they will help you with that. Fine. Let me stop for the day, right? Because I need to sign off now. So best of luck to you all. I hope you will continue learning, right? It was nice teaching you. Bye then.